In problem 27 in section 10.3, sorry, 9.3, we have a parabola and it's an inequality. And so far they've had us graph equalities. Graphing inequalities is really the same as graphing inequalities. Just with these inequalities that we have here, we're going to do some shading. And so let's look at what this is going to entail here. Let's first graph the parabola. If you notice, we could put a minus 0 with the y. I wrote the general form of the equation right down below it, right here. So we can tell, let's see, that we can get our vertex off of this pretty easily. The h is a positive 3, and then the k is 0. So there's our h and our k. I'm going to go ahead and label them because it's helpful when we go to find our c here in a minute. Okay, so our vertex is 3, 0. Let's go ahead and graph that. It's right here. Now, we're supposed to, if you remember, there's all kinds of things we need to find here. One of them is, since this is a y, since the square is on the x, we know this is going to open up or down. And because there's no negative out in front of the x minus 3 squared, we know it's going to open up. So this is going to be one that opens up. Okay. If we want to find the focus, we need to find C first. So we're going to find C. And how you find C, if you remember, you take the stretch or shrink factor that's in front of the square term. And since there's nothing there, there's an invisible 1 that I'm going to just kind of dot in there. So what A is equal to is 1, but that helps us find C because A is also equal to 1 over 4C. So what I'm going to do to find C is make this a fraction on the left side so I have a proportion and can cross multiply. 1 times 1 is 1, and 1 times 4C is 4C. So if you solve for C, C is equal to a fourth. Okay. So now how does that help me? Well, if I want my focus, and I'm going to kind of write on the graph up here since I know I can. Let me actually pick a different color so it'll show up a little bit better. The focus is, if you look at the book and the formulas there, is H, and then it's K plus C. Okay? So H is 3. We found that earlier. And K plus C would be, K is 0 and C is a fourth, so it would be 0 plus a fourth. That means that our focus is 3 a fourth. And that's going to be kind of hard to graph, isn't it? This is going to be so close right there, and I kind of missed it. It should be on the line of 3. So they're a little bit off. They should be on that line, vertical line on 3. Okay, so there's my focus. And now we have, let's see, we want our directrix. And our directrix, I'll just put D for directrix. Actually, usually the book uses a capital D. The directrix is y equal k minus c. Okay, so y equal, our k was 3, and our c was a 4, so it's 3 minus a fourth, which would be 2, let's see, 2 3/4. So the directrix is y equal 2 3/4. So 2 3/4. Okay, I could tell something was wrong, so I cut off the recorder and I found my mistake. If you look right here, I was finding my directrix. My directrix was k minus c. What did I plug in for k? What was k? K was 0 up here. What did I plug in? I plugged in 3. So I put the wrong number here. So the directrix, which I could tell something was wrong because my graph wasn't working out. The directrix is 0 minus a fourth because k is 0, and I just plugged the wrong number in. Okay, so it's y equal negative 1/4. Okay, so if I'm going to draw my directrix in, I'm going to draw it in this orange that I've been doing. It's going to be really hard to do it. It's going to be a horizontal line like this at a fourth, which is really hard to get on this graph because it's just with this big chunky stylus I'm using, but that'll represent it. Okay, so I've got my vertex, I've got my directrix. Now my axis of symmetry, I'm going to draw that in a pink color. It is just a vertical line through the focus and the vertex. So this is going to be my axis of symmetry right here. So I've got all the parts here. Really, in order to get some good points here, in the book really doesn't, if you look at their example, they don't go through that trouble, but I just am not comfortable just freestyling a parabola there by eyeballing it. So I'm going to plug in, what if x is 4? Okay, so let me come over to the side here. If x is 4, we have y, let's just put an equal in it for a minute. Y is equal to 4 minus 3 squared. Well, y would be equal to 1 squared, which is 1. So at x is 4, we get y is 1. I kind of missed it. And so since that's 1 away from the axis of symmetry, I'd have another one over here. If I wanted a really good graph, let's get something else. Let's see, what if I plugged in 5? 5 minus 3 would be 2 squared. I'm plugging it into the black equation that we started with, so y would equal 4. So at 5, we're all the way up to 4. And so there's going to, since that's 2 away from the axis of symmetry, we're going to have another point here. Now this makes me feel a whole lot better than just me eyeballing it and trying to get it the same distance away. Because I'm not real good at, some people could probably do a good job of saying it's the same distance away from the directrix and the focus. I can't do that, and I like to have better graphs than just slopping something up there, okay? So here is a graph of the equal, okay? Now, I have kind of messed up a little bit because I did not take into account, I just drew the parabola, which is good. I needed to do that. And if I had a pencil and a piece of graph paper, I could fix this really easy. I'm going to try to fix this. And use the eraser tool here, which is not great. All right, so it probably looks pretty funky right now. Okay, so my plan didn't work. Here's what I'm going to do. I should have made this parabola dotted. So what I'm going to try to do is, actually, I didn't mean to put that white mark there, but I'm just going to kind of use a white marker to make my parabola look more dotted. Why am I doing that right now? Let me kind of get a few more little slots there. Let me finish when I was trying to use the eraser tool. Okay, let me do something like that. That parabola should be made out of dotted lines or dashed lines, not a solid line, and I'm going to circle in yellow the reason why. This less than right here means that I don't want to draw the parabola solid. I wanted to draw it with solid lines, dashed lines. Now that's kind of hard to do, even with pencil and paper, so if you drew it and then just went back and erased little pieces here and there, you'd have the same idea. So that takes care of the fact that there's no line under that inequality sign, because remember, you'd have to have a line under it if we want a solid figure. Think back to what we did in Algebra 1 with lines, and maybe even earlier this year at this point. Okay, now less than. Where would the areas less than be on this graph? The y's that are less than the parabola. You would be shading outside the parabola. Okay, so the parabola is going to climb faster, and so you don't want to shade inside the parabola. You want to shade outside the parabola. It's really kind of easy to see the ones down here. Like, let me make another one. You see where I'm drawing this one down here? These are easier to see because you can tell the y's are below the parabola, right? But as that thing climbs really fast, the outside the parabola is actually where we're going to shade. Another way to test that is to plug in a test point. For example, let's say I wanted to plug in, I wanted to get a point that would work. I could pick a point. Let's say I picked a point inside the parabola just to see if that's where I should shade. So let's see if we should shade in is 3, 4. Here's a point inside the parabola. If I want to check it to see if that's where I should be shading, I can plug that into the equation. Kind of out of room, so let me come up real high here. So y is less than x minus 3 squared. I'm going to plug in, I'm going to test the point 3, 4 to see if it works, okay? So I'm going to put it in this equation right here. So is 4, that's the y, less than, let's plug in the x of 3. Is 4 less than 3 minus 3 squared? Okay, well, what's 3 minus 3 squared? It's 0. So is 4, and 0 squared would be 0. Is 4 less than 0? No. That means that inside the parabola is not where these solutions are. They're outside the parabola. So I could actually just shade outside the parabola, and however far up I draw it, I would want to shade just everything outside the parabola. Since I put my arrows there, I'm just going to kind of stop. I might want to add a few more here. See if I can get it to take. I might want to add a few more shadings like right here at the edges just to show. But anyway, it's outside the parabola is the shading for that. Okay, I thought we'd look at 31 really quickly. It tells us to graph the equation, and each graph is half a parabola since the square root of a is greater than or equal to 0. Okay, what's going on here? Well, if we had looked at the form for this equation before they square rooted it, it would have been this one, because we have the square. We don't have the y with a square on it, do we? Actually, it would have been the other way around. No, that would have been right. Okay. No. I'm trying to make this fit one of the equations in the book on page 414, but it's not. I'm not going to do that. I'm confusing myself, so I'm just going to stop because we really don't need it. This is a pretty simple. Equation here. We really don't need to make it more complicated than it is, I guess. The thing about it is this was an equation that had a y squared equal to x, okay? So what they did was they square rooted each side. Now, they square rooted it. I didn't, did I? We didn't square root it. If we had square rooted it, we would have put a plus or minus on it. But they square rooted it and they didn't, so they only want the positive side of this parabola. So we could use what we know about parabolas to graph this. But this one might be an easy one to do just with the table of values. The thing about it is we only want the positive values here. So if we put a number like x is 0, the square root of 0 would be y, which is 0. If x is 1, the square root of 1 would be 1. We're not going to put plus or minus 1 because they didn't put a plus or minus in front of that radical. Another perfect square that'd be easy to plug in would be 4. Square root of 4 is 2. Let's do one more. 9. The square root of 9 is 3. So using this table of values, I could graph this pretty quickly. 0, 0, 1, 1, 4, 2, and then 9, 3. And what we're going to get here is just half a parabola. It's going to look like this, except it should have been more curved here, okay? Somehow I should be able to curve that a little bit more. We only have half a parabola, and the reason is they didn't, if it had been this, we would have had the whole parabola, but they did not have this plus or minus on it. So anyway, that's the reason why it's only half a parabola. You can check that by putting in your graphing calculator and see that it looks like this.